Okay, I'm back, and now we want to continue our review for the Unit 4 lecture exam in astronomy by talking about Lesson 23, which is dark matter, dark energy, and the fate of the universe. So make sure and read the learning objectives for this lesson, and then be reading Chapter 18 out of your textbook. All right, so what is causing the universe to collapse? Okay, it's going to be gravity. Gravity is going to be caused by mass. So where is the mass coming from? So the mass could be caused by light itself. So light has energy, and energy is equal to mc squared. So even a photon of light, an electromagnetic wave, has a type of mass that goes with it. However, you notice that the mass of the universe caused by light itself is only 0.01%. So it's not enough to cause the collapse of the universe. So we're just going to ignore it. So that leaves us with two candidates: regular matter, which is going to be composed of atoms, nucleuses, protons and neutrons, quarks, leptons. So all of that is regular matter, and it makes up 4% of the universe. Then you also have the stuff that we call dark matter, which we don't really know what it is, but we do know that it has mass and it causes gravity. And we know that it makes up about 23% of the universe. Then you've got what would cause the universe to expand. So what would cause space and time to be expanding? So one is the initial Big Bang itself. So if you set off a stick of dynamite, it sets off a shock wave that expands. So space and time expanded because of the Big Bang. But we also have dark energy, which we said has the effect of being anti-gravity, and it is also causing the universe to expand. And dark energy makes up 73% of the universe. So it all comes down to who is winning. So is mass winning, which means the universe is going to collapse, or is the dark energy winning, which is making the universe expand? And remember that the correct way of viewing gravity is not the formula for gravity: force equals big G m1 m2 divided by r squared. That's the classical way of viewing gravity. So the correct way of viewing gravity is general relativity. And so you need to know what the critical density of the universe is. So density in general is given by rho, and it's going to be equal to mass divided by volume. However, because E equals mc squared, mass could also be caused by energy. So that instead of saying that this is regular density, we're going to call this the mass energy density. And so the mass energy density includes the mass of the universe, and it also includes the energy in the universe. And there is a critical mass energy density. So if you see it and it's got a C on there, then that stands for the critical mass energy density, and that would be the amount of mass and energy that would be necessary to stop the expansion of the universe. Okay? And then it can be calculated. So it's a number, and this number can be calculated based on the magnitude of Hubble's constant, h sub 0. And we've done it. So based on the current value of Hubble's constant and the current value of the gravitational constant, we put them into that formula there, and we calculated how much mass and energy would be necessary to stop the expansion. And it turns out there's not enough. So the current estimates for the amount of mass and energy in the universe is smaller than this number. So that means, according to our best guesses, the universe is going to expand forever. That's what we think is going to happen. So here is Einstein's equation for general relativity. Now you don't need to know this formula. So this formula is not going to be on the exam. However, you should recognize this symbol if I put it on the exam. So that's it's the Greek letter lambda, but it stands for the cosmological constant. And it basically represents the amount of dark energy in the universe. So dark energy is what's causing the expansion of the universe. The amount of dark energy is related to the magnitude of that constant. So in Einstein's equations, he's got a part of his equation over here that involves gravity, which is causing the universe to collapse. Then you got this part here that has this, which is causing the universe to expand. And then on the other side of the equal sign, you've got what is it doing. So this is the curvature of the universe, and then on this side of the equal sign is what's causing that particular curvature. And it all is coming down to what is winning. Is it the mass and energy of the universe, which is causing gravity, which is causing it to collapse, or is this thing winning, which is causing the expansion of the universe? And so I would like for you to know the names of the three kinds of curvatures of the universe, so that if there is exactly the correct amount of mass and energy of the universe, then this term and then this term over here would cancel each other out, and then we would live in a flat universe. And so if that was to happen, then the universe would expand, but eventually it would come to a stop. But it would take an infinite amount of time for that to happen. And so we say that we live in a critical universe. Now, on the other hand, so let's go back to this. What would happen if there was too much mass in the universe? So that would mean that this term over here would be bigger than this term here. So then there would be too much gravity and the universe would collapse. Okay, that would be a spherical curvature. And so that would be a recollapsing universe because the universe would collapse. Okay, then the third possibility is that there is not enough mass in the universe. So then that would mean that this term is going to dominate. And if this term dominates, then the universe is going to expand forever. And then you have the hyperbolic curvature to the universe. And now there are two possibilities. So you could have that there is not enough mass, and the universe will expand forever at a constant rate, at a constant speed. On the other hand, if there's really not enough mass in the universe, it's going to accelerate. So when I take this thing and I drop it, it's accelerating. Its speed is getting faster and faster and faster. Well, imagine that if instead of it going down, it went up and went faster and faster and faster. So that would represent the expansion of the universe at an ever faster rate. That's what we really think the universe is. So we think that we actually live in an accelerating universe. It is expanding at an ever faster rate. That's what um, Hubble's research when he looked at the galaxies, and he noticed that the further away the galaxy was, the faster it was moving away from the Earth. So according to Hubble, it kind of verifies this accelerating universe that we live in. And so I'm not going to ask you anything about the orbit of planets, okay? But notice how similar it is. So that if there's not enough, if a orbiting object doesn't have enough energy, then it's stuck in a bound orbit. If it has enough energy, it can escape. And so it goes away from the thing that was holding it down at a faster and faster rate. And so that was a hyperbolic orbit. Okay, so what's going to happen to the Earth in the future? So let's take a break, and when we come back, we'll talk about that.